morning students, welcome for the next part or next session of the aldehydes and ketones. In the first class we have already discussed about the methods of preparation of the aldehydes. Today we are going to discuss about methods of preparation of ketones. There exist only 3 methods of preparation for the ketones. Let us study one by one. Okay, first one. From acyl chlorides okay, consider we all know about the general formula of the acyl chloride, that is RCOCl. It is what? Acyl chloride. Here, whenever this acyl chloride reacts with dialkyl cadmium, what? It should react with dialkyl cadmium. It is what? Acyl chloride. Here, this Cl is replaced by this R. Consider this one as RH. Okay. Here, what do you get? Let R this is from R dash plus this cadmium reacts with the Cl, cadmium chloride. Okay, here to balance this reaction, consider here 2 molecules of RCOC, RH. Okay, consider this one as also 2 molecules. This is what? Ketone. Let us consider one example. And consider this molecule. What is this one? Ethanol chloride. And ethanol chloride reacts with dimethyl cadmium. What? Dimethyl cadmium. Okay, dimethyl cadmium. What happens? This Cl is replaced by this CH3 group. CH3, CO, CH3 plus cadmium chloride. Okay, this is dimethyl cadmium. Dimethyl cadmium. Okay. This is propanol. To balance this reaction, write 2 here and write 2 here also. This is first method of preparation of the ketones from acyl chloride. Next one. Second one. From nitriles. From what? Nitriles. Consider nitriles. RCN. Okay, RCN. Carbon is possessing partial positive charge here with respect to nitrogen, and this nitrogen is possessing partial negative charge. Please remember this one. Okay. Now, this one will react with the Grignard reagent, RMGX. You all know about RMGX means Grignard reagent, consider R dash. Here, magnesium is possessing, it is a metal, and R means it is having the carbon. If you compare the electronegativity of the carbon and the magnesium, carbon will have the higher electronegativity, therefore it will possess partial negative charge and magnesium will possess partial positive charge. During the reaction, what happens? See here. During reaction, what happens? this R group will attack on this carbon. Okay, because it is carrying negative charge, it is carrying positive charge. It will attack on here. Therefore, number of bonds with the carbon becomes 5 whenever this R group of the Grignard reagent attacks this one. Therefore, one of the bond will shift to here. Our nitrogen will complete negative charge. Then what happened? See here. R C double bond N. Now this is carrying negative charge, and this R dash will be joined here. R dash will be joined here. Okay, this MgX positive charge part will attach to the negative charge nitrogen. Other ಇಲ್ಲಿಗೆ ಏನು ಬಂತು MgX. Okay, here we have got this intermediate. Now this is an intermediate of the reaction. This undergoes acidic hydrolysis. Acidic hydrolysis. Here breaking of the compound takes place. Compound illi break agtade. Yav reeti? Look at here. One part here, OH will be added, and another part, look at here. Here, bond is going to break here. Here, in two ways it will break. One way will be broken down here also. Illu kuda bond break agutade. This OH and H will be joined here. One molecule of water laga OH idike join agati, hydrogen illige join agati. In another way, in one more water molecule here, H2 is joined to this part. H2 is joined here. O will be joined. ಇಲ್ಲಿ O join agati. Angare ಎಲ್ಲವನ್ನು ಸೇರಿಸಿ ಬರೆಯಬೇಕು. R C double bond O R dash. R C double bond O R dash. ನಿಮಗೆ ಗೊತ್ತಾಗಲಿ ಹೇಳೋದಾದ್ರೆ I will write it using the white chalk piece. Okay. Here plus NH H2 plus NH3 plus this is MgOHX. Okay. Now this is what? Ketone. This is ketone. This is nitrile. This is Grignard reagent. Okay. This way ketone is formed. ನೀವು ಏನು ಬರೀಬೇಕಂತಂದ್ರೆ ಇವೆಲ್ಲವನ್ನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ನೀವು ಈ ಬ್ರೇಕಿಂಗ್ ಐತಲ್ಲ ಇದು ತೋರಿಸೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಎಕ್ಸಾಮ್ ಮಾಡೋದು ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರೆದ್ರೆ ಸಾಕು. ಏನು whenever nitrile and reacts with Grignard reagent forms an intermediate which is followed by acidic hydrolysis gives ketone. ಇಷ್ಟನ್ನು ಮಾತ್ರ ಬರೀಬೇಕು. Example. Let us take example. One example. Whenever ethane nitrile, you can hear ethane nitrile. Consider two carbon atoms and with the E plus this reacts with ethyl magnesium chloride. Ethyl magnesium chloride. Notri and intermediate ಏನು ಬರ್ತದೆ ಈಗ CH3 C double bond N to this C2H5 will be added here. MgCl will be added. Now this will undergo acidic hydrolysis to give what? Here it will be broken down. CH3 CO C2H5 here plus NH3 plus Mg what? Name of this compound. Name of this compound. Butane 2O. This is what? Butane 2O. Okay. This is ethyl magnesium chloride. Ethyl magnesium chloride. This is one example for the formation of ketone from nitrile. Okay. Next to move towards the third method of preparation. Okay. Third one. From benzene or substituted benzene. From benzene or substituted benzene. Okay, consider whenever benzene reacts with acyl chloride. Benzene reacts with acyl chloride in presence of anhydrous aluminum chloride catalyst. Anhydrous aluminum chloride catalyst. What happens? This RCO group will join to benzene ring. Okay. This is nothing but electrophilic substitution reaction of the benzene. Okay, you already discussed this one in case of the alcohol. Alcohol chapter ಬಂದಿತ್ತು ಅಲ್ಲಿ ಫಿನಾಲ್ ಯೂಸ್ ಮಾಡಿದ್ದೀವಿ ಇದನ್ನ ಅಷ್ಟೇ, ಮತ್ತೇನು ವ್ಯತ್ಯಾಸ ಇಲ್ಲ. Here CO will be joined. It is what? Ketone. It is ketone. Let us take one example. Okay, and benzene reacts with ethanol chloride. Ethanol chloride in presence of anhydrous aluminum chloride catalyst. In presence of anhydrous aluminum chloride catalyst. Then what happens? The CH3CO group will be joined to here. This is what? Acetophenol. Acetophenol. These are what? These are the three methods of preparation of ketones according to your second PUC syllabus. Okay. Okay. Let us discuss about the physical properties of the aldehydes as well as ketones. First one, boiling point. Boiling point. In that one, first point, boiling point of aldehydes and ketones increases with increase in molecular mass. Increases with increase in molecular mass. Why? You already know that whenever molecular mass increases, Van der Waals force increases. As Van der Waals force increases, boiling point increases. Second one. These are having means aldehydes and ketones. Aldehydes and ketones. Ketones will have higher boiling point than ethers and hydrocarbons of comparable molecular masses. ಅಂದರೆ ಯಾವ ಈಥರ್ ಮತ್ತು ಹೈಡ್ರೋಕಾರ್ಬನ್ಗಳ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್ ಈ ಆಲ್ಡಿಹೈಡ್ ಮತ್ತು ಕೀಟೋನ್ ಅಷ್ಟೇ ಇರ್ತದೋ ಅಥವಾ ಆಲ್ಮೋಸ್ಟ್ ನಿಯರ್ ಇರ್ತದೋ ಅವುಗಳಿಗಿಂತ ಆಲ್ಡಿಹೈಡ್ ಮತ್ತು ಕೀಟೋನ್ಗಳ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಏನಿರ್ತದೆ ಜಾಸ್ತಿ ಇರ್ತದಂತ. ವೈ? ಬಿಕಾಸ್ ಡ್ಯೂ ಟು dipole interaction, Look at here. It is what carbonyl group of the aldehyde and ketone. Okay. Here consider this group. Here this oxygen is having partial negative charge, this carbon is having partial positive charge. Here this oxygen having partial negative charge, this carbon is having partial positive charge. These two will interact using dipole interaction. They are possessing of dipoles. Because of this dipole force, they are having a higher boiling point. In ethers and in hydrocarbons, there exists only van der Waals force. There is no dipole force. Okay. Next point. Aldehydes and ketones will have lower boiling point than alcohols. Due to absence of strong hydrogen bond. In case of alcohols, there exists intermolecular hydrogen bond, but in case of aldehydes and ketones, there exists dipole interaction. Okay, two alcoholic molecules will possess hydrogen bond. Two aldehydes or ketone molecules will possess dipole interaction. The hydrogen bond is stronger than the dipole interaction. Therefore, alcohols will have the higher boiling point than the aldehydes and ketones. Okay. This is about boiling point of aldehydes and ketones. Now let us discuss about the solubility. Second physical property. Solubility of aldehydes and ketones in the water. Okay. Solubility of aldehydes and ketones. First point, lower aldehydes and ketones up to 4 carbon atoms. ಅಂದ್ರೆ ಏನು 4 ಕಾರ್ಬನ್ ಆಟಮ್ಗಳು ಇರತಕ್ಕಂತ aldehydes ಅಥವಾ ketones. Lower aldehydes and ketones up to 4 carbon atoms soluble in water or miscible in water. Miscible ಅಂತಂದ್ರು soluble ಅಂತ ಅರ್ಥ. Okay, miscible in water at all proportions. Okay, because therefore hydrogen bond of with water. With water. ಇಲ್ಲಿ ನೋಡ್ರಿ ಕಡಿಮೆ ಕಾರ್ಬನ್ ಆಟಮ್ಗಳು ಅಂದ್ರೆ 4 ಕಾರ್ಬನ್ ಆಟಮ್ ವರೆಗೂ ಅಂತ ಅರ್ಥ ಆಯ್ತು. ಇಲ್ಲಿವರೆಗೂ ಇದು ಅಪ್ಲೈ ಆಗ್ತದೆ. ಇರ್ತಕ್ಕಂಥ ಆಲ್ಡಿಹೈಡ್ ಮತ್ತು ಕೀಟೋನ್ಗಳು ವಾಟರ್ ಜೊತೆ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತಾವು. therefore they are soluble in the water. ಯಾವ ರೀತಿ ಇಲ್ಲಿ ನೋಡ್ರಿ, let us consider this one as water molecule. Okay, here it is the negative charge, these are positive charge. Okay, and now consider carbonyl group. Carbonyl group consider ಮಾಡ್ಕೊಳ್ಳಿ. Okay, now here partial negative charge, partial positive charge. Now between these two, here hydrogen bond is formed. This is what? Hydrogen bond. Therefore they are soluble in the water. Next question is, what happens to the aldehydes and ketones with carbon atom with more than 4 carbon atoms? What happens to those aldehydes and ketones? That is the question now. Second point, the higher aldehydes and ketones, higher aldehydes and ketones are not soluble in water due to bulky alkyl or aryl group. ಕಾರ್ಬನ್ ಆಟಮ್ಗಳ ಸಂಖ್ಯೆ ಜಾಸ್ತಿ ಆದಂಗೆ ಆ ಆಲ್ಕೈಲ್ ಮತ್ತು ಅರೈಲ್ ಗ್ರೂಪ್ ನಲ್ಲಿ ಅದು ಬಲ್ಕಿ ಆಗ್ತದೆ. ಕಾರ್ಬನ್ ಆಟಮ್ ಜಾಸ್ತಿ ಆಗುವಂಗಾದ್ರೆ ಅವು ಬಲ್ಕಿ ಆದಂಗೆ ಅದು ಆಲ್ಕೈಲ್ ಮತ್ತು ಅರೈಲ್ ಗ್ರೂಪ್ ಸೈಜ್ ದೊಡ್ಡದಾದಂಗೆ ಏನಾಗ್ತದೆ, ಅವು ದೇ ಆರ್ ನಾಟ್ ಸಾಲ್ಯುಬಲ್ ಇನ್ ದ ವಾಟರ್. ಹಿಯರ್ ದೇ ಆರ್ ನಾಟ್ ಸಾಲ್ಯುಬಲ್ ಇನ್ ವಾಟರ್ ಡ್ಯೂ ಟು ಬಲ್ಕಿ ಆಲ್ಕೈಲ್ ಅಂಡ್ ಅರೈಲ್ ಗ್ರೂಪ್. ದಿಸ್ ಆಲ್ಕೈಲ್ ಅಂಡ್ ಅರೈಲ್ ಗ್ರೂಪ್ ಆರ್ hydrophobic in nature. Hydrophobic in nature. They are having hydrophobic nature. Therefore, they are not soluble in the water. This hydrophobic nature is not having tendency towards the water. Therefore, they are not soluble in the water. This is applicable. This point, the last point, is applicable for the aldehydes and ketones with the carbon atoms more than 4. Okay, this is about the physical properties of the aldehydes and ketones. Okay students, let us discuss about the chemical properties of aldehydes and ketones. Okay, in that one, first one is nucleophilic addition reaction. Nucleophilic addition. Okay, this nucleophilic addition is explained on the basis of the structure of carbonyl group here. Okay, here look at the CO. Carbon is possessing, the carbonyl carbon is possessing partial positive charge and carbonyl oxygen is possessing partial negative charge. Therefore, this oxygen acts as a nucleophilic center and this carbonyl carbon acts as electrophilic center. Electrophile means what? Which is carrying positive charge. Nucleophile means what? Which is carrying negative charge. Therefore, on this carbon, any negatively charged species can attack. On this oxygen, any positively charged species will attack on these oxygens. Here, because of possessing electrophilic center on the carbonyl carbon, the aldehydes as well as ketones, ಎರಡಕ್ಕೂ applicable ಇದೆ, ಯಾಕಂದ್ರೆ ಎರಡೂ carbonyl group. The aldehydes as well as ketones undergo nucleophilic addition reaction. ಅಂದ್ರೆ ಯಾವುದೋ ಒಂದು ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಬರ್ತದೆ, ಆ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಒಂದು ಈ ಕಾರ್ಬನ್ಗೆ ಆಡ್ ಆಗ್ತದೆ ಅಷ್ಟೇ. ಯಾವುದೇ ಗ್ರೂಪ್ ಬಿಟ್ಕೊಡೋದಿಲ್ಲ, ರಿಪ್ಲೇಸ್ ಅಲ್ಲ, ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಅಲ್ಲ, ಇದು ಆಡ್ ಆಗೋದಲ್ಲ. ಓಕೆ, ಗೊತ್ತಿರಲಿಲ್ಲ. ಓಕೆ, ಇನ್ ದಟ್ ಒನ್ now consider mechanism of this reaction. Mechanism. This involves two steps. Okay, this mechanism involves two steps. Step number one. In step number one, what happens? Look at here. Consider this carbonyl group. It is maybe aldehyde or ketone. Idenagirutte aldehyde or ketone ಆಗಿರುತ್ತೆ. Consider, let us consider this one as A, this one as B. Okay? Now this is possessing partial negative charge. Partial positive charge. Here. Now let us consider the first step. A nucleophile. One nucleophile la consider ಮಾಡ್ಕೊಳ್ಳಿ. That nucleophile will attack on this carbon. Then what happens? This double bond present between carbon and oxygen will shift to oxygen automatically. This happens in the first step. Okay? This is slower step. This slow step ಅನ್ನೋದು ಗೊತ್ತಿರಲಿ. Next, here this is having this structure, is having planar structure. Why? Because this carbon is having sp2 hybridized. This carbon is being sp2 hybridized. This carbonyl group will have, means this aldehyde or ketone molecule will have the planar nature. From any one side, the nucleophile will attack the carbonyl carbon. Then what happens? Look at here. This double bond when it shifts to oxygen, negative charge will be developed there. Okay, now its position will be changed. Geometry will be changed, not position. The geometry of this carbon will change here. Now this becomes nucleophile. Here nucleophile will be added. Okay. Now this its geometry will changes from planar to the tetrahedral. ಈಗ tetrahedral ಆಗ್ತದೆ ಈಗ. ಯಾಕಂದ್ರೆ ಡಬಲ್ ಬಾಂಡ್ ಇದೆ ಎಲ್ಲವೂ ಸಿಂಗಲ್ ಬಾಂಡ್ ಆಗಲ್ಲ. Now it has changed to tetrahedral structure. Is it? Now this is oxygen with negative charge. Negative charge. This is what a tetrahedral structure. This whole thing happens in step number one. Now consider step number two. In step number two, what happens? This one, consider that group here, tetrahedral group. Now, this group undergo a fast mechanism. In that fast mechanism, this oxygen carrying negative charge will catch or will snatch or it will attach to one of the proton or hydrogen from the reacting medium. One reacting medium, reacting hydrogen okay, it will get the hydrogen. is the oxygen, will get hydrogen. Okay? This is what? The final product. Nucleophilic added product. This is addition compound. This is called as what? Addition compound or addition product. Because this is nucleophile bando add again. Then negative charge. Okay? This is what? The mechanism of nucleophilic addition of the aldehydes and ketones. Okay? Now, note. First point. Towards nucleophilic addition. Nucleophilic addition. Aldehydes are more reactive than ketones due to two reasons. Due to what? Two reasons. Okay. First one, steric reason. Steric reason. Okay? Look at here. In case of aldehydes, the carbon is attached to one alkyl or aryl group, and the one is hydrogen, smaller hydrogen group. Therefore, on this carbon, easily nucleophile can attack. This R size bulky smaller iರಲಿ ಅದು ಒಂದೈತಿ. ಇನ್ನೊಂದು ಹೈಡ್ರೋಜನ್ ಇದೆ ಎಲ್ಲಿ ಆಲ್ಡಿಹೈಡ್ ಅವಾಗ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಇದ್ರ ಮೇಲೆ ಅಟ್ಯಾಕ್ ಮಾಡಕ ಸ್ಪೇಸ್ ಜಾಸ್ತಿ ಸಿಗ್ತೈತಿ. Therefore, nucleophile will easily attack on carbonyl carbon. But here, in case of ketone, what happens? Two bulky R groups are present here. These are bulky. Two bulky R groups are attached there. Iveredu bulky groups ಗಳು ಇರ್ತಾವ ಅಂತಂದ್ರ ಇಲ್ಲಿ ಒಂದು ಹೈಡ್ರೋಜನ್ ಐತಿ, ಇಲ್ಲಿ ಎರಡು R group ಗಳು ಇರೋದ್ರಿಂದ the nucleophile cannot easily attack on the carbonyl carbon in case of the aldehydes or in case of the ketones. Okay, this is what steric reason. Okay, ಅಂದ್ರೆ ಆ ಕಾರ್ಬನ್ ಮೇಲೆ ಅಟ್ಯಾಕ್ ಮಾಡಕ್ಕೆ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಗೆ ಜಾಗ ಇಲ್ಲ, ಸ್ಪೇಸ್ ಇಲ್ಲ ಅನ್ನೋದೇ ಏನಂದ್ರೆ ಸ್ಟೀರಿಕ್ ರೀಸನ್ ಅಂತ. ಇನ್ನು ಎರಡನೇ ರೀಸನ್ ಯಾವುದು? ಎಲೆಕ್ಟ್ರಾನಿಕ್ ರೀಸನ್. Electronic reason. Okay, here in aldehydes, another one is ketone. You all know that this is possessing partial positive charge. Here also this is possessing partial positive charge. You all know that this alkyl group releases the electron towards the carbon. Here also two alkyl groups releases the electron towards the carbon. This release of electron density decreases positive charge on carbon. ಇದೇನ್ ಮಾಡ್ಬಿಡುತ್ತೆ? ಇದು ರಿಲೀಸ್ ಆಲ್ಕೈಲ್ ಗ್ರೂಪ್ಗಳು ಕಾರ್ಬನ್ ಕಡೆಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಲೀಸ್ ಮಾಡ್ತಾವೆ. ನಿಮ್ಗೆ ಗೊತ್ತೈತೆ ಆಲ್ಕೈಲ್ ಗ್ರೂಪ್ಗಳು ಯಾವತ್ತು ಎಲೆಕ್ಟ್ರಾನ್ ರಿಲೀಸ್ ಮಾಡೇ ಮಾಡ್ತಾವೆ. ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಲೀಸ್ ಮಾಡೋದ್ರಿಂದ ಕಾರ್ಬನ್ ಮೇಲೆ ಇರ್ತಕ್ಕಂಥ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಕಡಿಮೆ ಆಗ್ತೈತಿ. ಇಫ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ on the carbon decreases, the nucleophile will not attack on the carbon because it needs the positive charge. Okay, ಅದ್ಮೇಲೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದಲ್ಲ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಅಟ್ಯಾಕ್ ಮಾಡೋದು. ಈಗ ಈ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಲೀಸ್ ಮಾಡೋದ್ರಿಂದ ಕೀಟೋನ್ ಒಳಗೆ ಎರಡು ಗ್ರೂಪ್ ಅದಾವೆ, ಆಲ್ಡಿಹೈಡ್ ಒಳಗೆ ಒಂದೇ ಗ್ರೂಪ್ ಐತಿ. Therefore, in case of ketone, the positive charge on the carbon will be decreased at a more extent than the aldehydes. Aldehyde ಗಿಂತ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬಹಳ ಕಡಿಮೆ ಆಗೋದ್ರಿಂದ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಇದ್ರ ಮೇಲೆ ಅಟ್ಯಾಕ್ ಮಾಡಕ್ ಹೋಗುದಿಲ್ಲ. ಅದಕ್ಕೆ ಆಲ್ಡಿಹೈಡ್ಸ್ ಏನಪ್ಪ ಅಂದ್ರೆ ಎರಡು ರೀಸನ್ ಇಂದ the aldehydes are more reactive towards the nucleophilic addition reactions than the ketones. Okay, this is about the nucleophilic addition reactions. Okay. Okay. Let us consider the first reaction of nucleophilic addition reaction. That is first one, addition of cyanohydrin. Addition of not cyanohydrin, addition of hydrogen cyanide. Addition of hydrogen cyanide. HCl. Okay, consider here. This is aldehyde or a ketone. Whenever this reacts with HCl, this Cn will be the nucleophile here. Okay, then it becomes like this. This Cn will be joined here. Here two groups are attached. Here the H will be joined along with oxygen. OH. This is what? The cyanohydrin product. Cyanohydrin. Okay, this is the general reaction for addition of hydrogen cyanide to the aldehyde or ketone. Let us take one example here. What is this one? Methanol. This is methanol or acetaldehyde. Acetaldehyde when reacts with hydrogen cyanide. What do you get? Here Cn will be joined. Here H will be there. Here CH3 is already there. This is OH. This is acetaldehyde. Cyanohydrin. This is acetaldehyde, cyanohydrin. Let us take one more example. Okay, ಇನ್ನೊಂದು example ತಗೊಂಡ್ರಿ. ಈ ಸಲ ಏನು ತಗೊಂಡು ketone ತಗೊಂಡು. Okay, and propanone or acetone. When acetone reacts with hydrogen cyanide, what do we get? Here Cl will be joined. Here CH3 is already there. Here also one more CH3 is there. Here OH. This is what? Acetone. This is what? Acetone cyanohydrin. Okay, let us discuss about the mechanism of this addition of hydrogen cyanide. Mechanism. This is slower. This is slower reaction. Actually, mechanism is very slow. Therefore, Cn minus is generated using a base OH minus. This is what? A base. In the base na ತಗೊಂಡ್ಬಿಟ್ಟು ಇಲ್ಲಿ Cn minus nucleophile ನಾವು ಜಲ್ದಿ ರಿಲೀಸ್ ಮಾಡ್ತೀವಿ, ಜನರೇಟ್ ಮಾಡ್ತೀವಿ. Otherwise the reaction will take place but at slower rate. Please remember that one. See here. Let us discuss about the production or generation generation of the Cn minus. Consider here HCl. whenever this HCl reacts with a base OH minus, what happens? OH react with hydrogen, forms the water plus Cl minus is generated. ಈಗ Cl minus generate ಆಗುತ್ತೆ. Okay? Then what happens? This will attack on aldehyde or ketone. ಇದು aldehyde or ketone ಮೇಲೆ ಏನಾಗ್ತದೆ? ಅಟ್ಯಾಕ್ ಮಾಡುತ್ತೆ. Consider aldehyde or ketone. This is aldehyde or ketone. This is planar in nature. Okay? You all know that this is carrying partial positive charge, this is carrying partial negative charge. Now, this will react with the Cn minus. Okay, what happens? The Cn will attack on carbon and this double bond will shift to oxygen. Then this planar structure will change into tetrahedral. The tetrahedral agutega. Okay? This is A and this is B. This is O minus. This is O minus. Okay. Now it will catch hydrogen from the water, hydrogen from the reacting medium or the water. The water ಏನಿತ್ತಲ್ಲ ಇಲ್ಲಿಂದ ಅದೇ ಮಾಡ್ತದೆ hydrogen ನ ತಗೊಂಡ್ಬಿಡ್ತದೆ. Again OH is generated, that OH comes for the production of Cl minus from the one more HCl molecule. ಅದು ಇನ್ನೊಂದು HCl molecule ಇಂದ ಅದನ್ನ ತಗೊಳ್ತದೆ. Okay? Using the pink color. Okay? Now we are at the final compound, final product. This is the final one. Okay, this is what mechanism of this is okay. This is step number 1. Here, this is step number 2. This is what mechanism. This is okay. Wait, this is tetrahedral. And this one is cyanohydrin. Cyanohydrin. This is what mechanism of addition of hydrogen cyanide to the aldehyde or ketone. Okay. Okay. Let us study about the second reaction of addition of nucleophilic addition reactions of the aldehydes and ketones. That is addition of sodium hydrogen sulfide. HSO3, sodium hydrogen sulfide. Okay, first let us study about the general reaction. Okay, whenever this reacts with sodium hydrogen sulfide, NaHSO3, this HSO3 will be the nucleophile here. This will attack on carbon SO2H. Actually OSO2H. And here to the oxygen sodium is added. Now this one will undergo proton transfer here. Proton transfer here from the reacting medium. Proton will not be snatched. Proton will not be gained by this intermediate. ಇಲ್ಲಿಂದ ಪ್ರೋಟಾನ್ ಅದು ಬೇರೆ ಕಡೆಗೆ ತಗೊಳ್ಳೋದಿಲ್ಲ, ಇಲ್ಲೇ ಎಕ್ಸ್ಚೇಂಜ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ತಾವೆ. ಯಾಕೆ? This oxygen is carrying negative charge. This SO3 group is also carrying negative charge. Always salt of stronger acid is formed. Always salt of stronger acid is formed. ಅದಕ್ಕೆ ಏನಾಗ್ತದೆ? This sodium will be exchanged between SO3 and O minus group. Okay? And the final product ಏನು ಬರ್ತದೆ ನೋಡ್ರಿ ಈಗ. OSO3Na plus OH. This is sodium bisulfite product. Bisulfite product. Let us consider two examples here. Example number 1. Acetaldehyde. An acetaldehyde reacts with sodium bisulfite. Sodium bisulfite. What happens? Directly write the product. Acetaldehyde bisulfite is formed. Bisulfite is formed. Take one more example. And acetone is reacted with sodium bisulfite. Sodium bisulfite. What happens? Again same. ಏನು ಚೇಂಜಸ್ ಇಲ್ಲ, ಅಲ್ಲಿ ಗ್ರೂಪ್ಗಳನ್ನು ಮಾತ್ರ ಇವೆರಡು ಗ್ರೂಪ್ ಅದೇ ರೀತಿ ಉಳಿತಾವೋ. ಇವೆರಡು ಗ್ರೂಪ್ನ ನೀವು ಜಾಯಿನ್ ಮಾಡ್ಕೊಳ್ರಿ, ಬೇಕಾದ ಆಲ್ಡಿಹೈಡ್ ಇರಲಿ, ಬೇಕಾದ ಕೀಟೋನ್ ಇರಲಿ. ಓಕೆ, this is what acetone bisulfite. This is what acetone bisulfite. These are what about the nucleophilic addition reaction of the aldehydes and ketones. Okay, this is the end of the today's class, and tomorrow we are moving towards the second chemical property of the aldehydes and ketones. Okay, thank you.